Alright, recording started. Hey guys, my name is Professor Addison, and today we got Madav Nair in the call who taught me everything. My physics master, Madav Nair. Can you introduce yourself?
Yeah, that's good, guys.
So this is why it's a particle. This is
What's it?
this is why sorry Mr. Nair. This is why light is a particle, and I'm on the right side. I'm right. Why light is a wave model. Right. Now we'll do why it's a wave model really quick. Well, because we know, right? If you have two people, say this is me, and this is Madav right here. Sorry guys, Madhav. If we were to pull, say, two curtains, right? Let's say we're pulling a curtain, and we're to shine two light at the same time. So this is the window shining light at the same time in the same place. Now, if it was a particle, these particles will bounce off as they meet in the middle of these two light rays. But because it doesn't, it shows that these waves here should be actually more brighter than anywhere else because the peaks and troughs connect with each other. Quote unquote, the interference pattern and the constructive interference when it goes higher, when the two peaks meet each other, that's why it becomes lighter in the middle. Now this is why it's a wave. But if it's a wave, but why would it be a particle? Now, because if we have the metal shining area, right? Say this is a metal, and we have some sort of light. And this is what Madav tried to explain to me for the past 40 minutes. I could not understand because I'm a bit of a silly goose. But he managed to make me understand this because this is what Madav said. If if it was a wave, right? The wave model explains that the intensity, no matter what intensity, will eventually give the electrons on this metal sheet, right? Give it enough electrons, enough energy to emit. However, the scientists have found out, alright, so this is me and Madav, scientists, we have found out that this does not happen. Matter of fact, if this was to be red light, I think the lowest frequency light, I reckon, if this was to shine at it constantly, even if you had 20 different lights shining at it, the intensity will increase, but the frequency will remain the same. And the wave model would eventually give it enough energy to light out, right? But it doesn't. So that is why it's not a wave model, but it's actually a particle model. But what is that? So basically, in the light, it will shine a bunch of like photons, and eventually, if you go here, right, if there's a bunch of photons, and these photons are called let's see, what are they called? They're called packets or quanta. They basically, like, I thought they're quanta of like different, like a bunch of waves together, but Medal quickly disproved that. But I'm not really sure what they are. But they're just photons. Basically, what they do is if they have a certain amount of frequency, and they shoot down these electrons, it will give it enough energy to actually eventually go out, and that's what we call the threshold frequency. Sorry, I apologize for my writing here. Threshold frequency, and that's what it is. It will give it enough threshold frequency to eventually dip out. To say bye bye, and that is why it's a particle and not a wave. Now, the last question is I had, right, Mr. Madav. I want you to explain why is the both a particle and a wave? Why does it have both properties, Madav?
Um, because it has both properties because it acts in ways that the wave acts, and it acts in ways that a property acts. Because we know it's a wave because of how when you conduct a double slit experiment, how instead of just going straight through, it has like interference patterns, and then that creates like a diffraction pattern. And then
Exactly.
we also know that it's a particle. We also know it's a particle because of the photoelectric effect,
Yep. So
and
photoelectric effect.
yeah, that's pretty much it, bro. Like,
So guys, if you're struggling to understand, we use the photoelectric effect to prove that it's a wave, that it's a particle model. And we also use the Young's double split experiment to prove that it's a wave. Thank you guys, that's enough from me and Madav Naya and Professor Addison. And I'll see you guys till next time, guys. Thank you.
that's how you record your YouTube